Hi folks, I'm Wayne Sebens. I'm a software architect at Repit, a global PropTech company. I'm excited to be presenting at dotnet Conf. I'll be presenting Modernizing a 17th century Italian English dictionary. That's a side project of mine involving a dictionary from a few hundred years ago, vector embeddings, and Aspire. I'm based in Brisbane, Australia, where we're just getting into that classic Aussie summer heat. I'm going to start with some brief history and linguistics, just to give some context before I get into the good .NET-y stuff. I participate in historical European martial arts, or HEMA. That's actually me in the grey jacket in the bottom left. It's like sport fencing, but we use a wide range of historical weapons like longswords, rapiers, and sabers. As many different types of armaments as there are, there's also as many styles, as historical fencing masters all over Europe often wanted to set themselves apart from others. Many of them wrote their own manuals, treatises, and manuscripts from Europe over the course of history, and these are the basis of what we learn from, reconstructing the techniques that they describe. If you've seen the film The Princess Bride, think of the back and forth in the sword fight between Inigo Montoya and Wesley on the cliff top. You are using Bonetti's defense against me, huh? You must expect me to attack with Capo Ferro. Naturally, but I find that Tybalt cancels out Capo Ferro, don't you? Unless the enemy has studied his Agrippa, which I have. Bonetti, Capo Ferro, Tybalt, and Agrippa were each fencing masters of the 16th and 17th centuries, who taught fencing or published texts that have survived until today. Most of these and other original texts aren't written in English though. For example, that image on the right is from an Italian knight and fencing master, Fiore dei Liberi, who wrote Fior di Battaglia, the Flower of Battle, sometime before 1409 in Middle Italian. That text is notable for being one of the oldest surviving martial arts manuals, and also for covering quite a range of armaments, from longswords and daggers, to polearms and spears, and even fighting on horseback. We almost always need to transcribe these original texts, not just into English from whichever primary language that we may speak or read, but from the older versions of languages that these were written in into their modern day versions, so that we can understand them. Even just a few hundred years ago, Italian and English were a bit different than they are today. And that's not even mentioning words or phrases that have fallen out of use. This very influential gentleman here is John Florio, who was a linguist, lexicographer, and translator from England during the Renaissance period. As you can probably tell from his very frilly ruff, that's the collar around his neck. And I mean influential in a few ways. Florio was connected and associated with many nobles and ambassadors during the times of Shakespeare. In fact, Florio was likely even an acquaintance of William Shakespeare, but that's a whole separate talk. Florio was also appointed Groom of the Privy Chamber to Queen Anna, the wife of King James I and VI. That's the same King James that united the English and Scottish crowns, as well as commissioned the King James Version of the Bible. Florio also influenced the English language as we know it today quite a lot. There are over 1,100 words that he is credited for introducing to the English language. Only Shakespeare and Chaucer have introduced more. This includes words like judicious, management, and transcription, as well as some much more vulgar words. Florio's work as a translator and lexicographer led him to publish 2 dictionaries on Italian words and their English definitions. Florio's second Italian-English dictionary, which he dedicated to Queen Anna, contains around 75,000 definitions. The largest before Florio's first dictionary only contained about 6,000. We today would call the versions of Italian and English from this period in time as Renaissance Italian and Early Modern English. While they're certainly recognizable as Italian and English, there's enough differences to seem weird to us today, especially when it comes to words or spellings that are no longer in use. You can probably see from how John is spelled with a capital I, the letter J doesn't quite exist in printed English at this point. So this makes Florio's dictionaries a valuable resource even today for anyone who is translating Italian texts from the Renaissance period. A fellow named Greg Lindahl has been hosting scans of the dictionary on his website for some time now. However, although they're well indexed, they're just images and a PDF of those images. If you read Stephen Toobe's yearly performance improvements in .NET blog posts, you might have heard of Project Gutenberg. Project Gutenberg also actually hosts a transcription of this dictionary as well in a few formats, including plain text with some markdown-like formatting. So this transcription is the first thing I needed to modernize Florio's dictionary. With the text in hand, I can parse the entries to obtain the Italian words with their English definitions, and then make the Italian word searchable. This here is part of the first page of entries in the dictionary, just to give some idea of how much even English has changed in the last 400 years, and also why OCR might struggle a bit. There's some things that immediately stand out, such as the long S in first, U being used in place of V in many words, like accusative, but also several cases, such as to, where a V might be used instead of a U at the beginning of a word. This here is an early form of an ampersand, when it used to denote the ET in ETC, as in etc. Et is Latin for and, cetera is Latin for remaining. Fun fact, the name ampersand itself comes from when reciting the alphabet would end with and per se and. You can see how that shortens to ampersand. Using a Y at the end of words wasn't particularly common, and it would generally be written with IE, as seen here in Abbey, and that's also why we use IES as the plural for those words. You can see a trailing E here on how, which also hints at why we use ED for past tense of several verbs. You'll also notice a U is often being used in place of a W when it's not at the start or end of a word. As it turns out, people in the 17th century didn't have any consideration for making machine-readable content. There's a few quirks and idiosyncrasies in how the entries are formatted that made parsing a little challenging. For example, idem here is a word from Middle English and Latin, meaning the same, as in, it has the same definition as the word above. For example, and excuse my pronunciation here, abacista has the same definition as abacieri above it, that is, a cluster of accounts, as in an abacist or an expert at calculation. Also, sometimes multiple different spellings would be listed in the same entry. In the example on the right, we have adua, adieu, and aduo, meaning by two and two, also a deuce at tennis. Yes, as in tennis, the sport played at Wimbledon. Italian, like many other European languages, has a diverse range of a language feature called conjugates. In English, we typically have simple conjugates for past, present, and future tenses of verbs, such as run, runs, running, and ran. However, many other languages, such as Italian, have far more conjugates for things like the singular and plural cases. In English, the addition of is and are before the verb kind of perform the same function. In Florio's dictionary, typically when the conjugates share a common lexeme or root, that's a kind of prefix, only the first word would be spelled fully, and the remaining lemmas, the different forms of the conjugate, would be written with only the stems or the suffix. However, when they don't have that common root, they're all actually written individually. So in the examples here, on the left, it's actually abolire, abolisco, and abolito on the left that all share a lexeme. But udire, odo, udi, and udito don't share a lexeme, so they're listed separately. Although this was definitely a challenge, parsing the dictionary and these entries wasn't impossible. The end is a website. I currently have it available on florio.sebs.au. I'm just going to jump over to it here. So this is an ASP.NET Core Razor Pages site, which I've styled to mimic Florio's dictionary. It only has a few pages, as it's mainly driven by data in CosmosDB. If you've used any online dictionary or encyclopedia before, using the website should feel familiar. I'll start by searching for Stelleo. As I type, we get the typical autocomplete results that we'd expect for the searches. However, if I include an accented character, we still get the expected results. If I backspace a bit though and misspell it slightly, we still manage to get results with the correct spelling. I'm just going to hit enter here rather than choosing one of the suggestions. This will take us to a results page, listing the closest matches and their definition from the dictionary. One of these contains a reference to another Italian word. If I hover over, we'll get a nice little popover showing the word's definition. And of course, I can click on one of the Italian words in the results, and it'll take me to a page for just that word's definition. The site links to its code on GitHub. However, I'm going to jump over to Visual Studio just so we can take a quick look at how all this comes together. So our first stop here is the Aspire app host. There's three main parts here. We have CosmosDB, the web app project, and this Vector DB Manager project. The DB Manager project is borrowing a concept from the Entity Framework Core migration sample in the Aspire samples repo. It's a separate worker job whose only responsibility is to check if the database is populated. And if it isn't, it will parse the dictionary and insert those words into the database. As I mentioned before, that database is currently CosmosDB with its recent support for vector embeddings. However, when I first started this project, I actually used Quadrant, and you can still see the library project for it. Using Aspire allowed me to focus on just the supporting code when I made that switch, rather than how to set up any local emulators or provisioning instances in the cloud. And of course, Aspire made it incredibly easy when it came to the final deployment into Azure. Making the dictionary search was the key part to making the website work. I needed to match with or without extended characters, but also handling spelling variations, and that's typically challenging for string match searches. However, vector similarity search algorithms that are used by vector databases, and now also included in many relational and NoSQL databases, like Azure SQL and CosmosDB, are great for fuzzy searches. However, just feeding the whole transcript of the dictionary through something like OpenAI's embedding service wouldn't really allow me to make just the Italian word searchable. The strength of OpenAI's embedding model is tokenizing entire sentences and having similar words located in similar parts of the vector space so that a sentence or question will strongly match a related sentence. I needed my own custom embedding model focused on just the Italian words. It was very easy to create one with ml.net. ml.net already has some pre-trained embedding models available for use out of the box. There are a few different sizes of the glove word embedding models, as well as the fast text and Wikipedia model. Because they're pre-trained, you don't actually need any data to use them. You can just set up an ml.net transformation pipeline like this and create a prediction engine from it. The output type here has a float array containing our embeddings. How can we go about training our own custom embedding model though? Over on the ml.net docs, there's an article on preparing data for training machine learning models. And way at the bottom is a section on preparing text data for training a sentiment classification model. At this step here is where the text data is transformed for training that classification model. However, we can actually just end right there. And that's it. ML.NET will train an embedding model just for our text input. Of course, you might want to customize it further. This featurized text transform is actually a few transforms bundled together. The first few steps here do some pre-processing, like converting to lowercase and removing unimportant words to reduce the vector space. Then the key, excuse the pun, is mapping each of those words to keys or categories for creating n-grams, which are just smaller groups of letters making up each of the words. The final step here is just a scaling function that's applied over the entire dataset to bring all the vectors to a value between 0 and 1 in each of their dimensions. These aren't the only transforms available to us though. ML.NET has several that could be applicable in some cases, and there's also some for use with images. You can also skip and customize some of these transforms, which is what I did for generating an embedding model that supports vector search scoped to just the Italian words. I only have two transforms here. Tokenizing the individual characters themselves as keys, and then generating n-grams of lengths 1 and 2, so-called unigrams and bigrams. It took some experimenting to get the n-gram lengths to get good results. While I could only use the unigrams to achieve the vector similarity search while tolerating typos and missing letters, it would mean that words that are anagrams of each other, such as melon and lemon, would score identically to each other. So this is where the addition of bigrams helped, as it reinforces the order of pairs of letters in the word. The normalized transform is still kind of being done, but I'm actually doing it outside of the ML.NET pipeline, as I needed to handle a case of converting uppercase V's to lowercase U's, just as one of those quirks of printed early modern English. Once my custom embedding model is trained, I'm then also saving it out to an Onyx file. This allows me to easily reuse the model across my solution without having to load and parse the dictionary and retrain the model at startup all the time. There's several improvements that I've planned for what I've built so far, and I'm especially excited about how new features in .NET 10 will enable them. First of all, Entity Framework Core now supports a new vector data type and enables vector searches. And in addition to that, it also enables hybrid search with CosmosDB for NoSQL. So this is going to allow me to simplify a lot of my query logic and as well improve the website search results a bit more. So far, I've created my own abstraction layers for generating embeddings. However, Semantic Kernel and the Microsoft Extensions AI library includes similar embedding and vector store abstractions. So I'm very interested in investigating how these may simplify my code base, especially when it comes to seeding the database. Overall, I'm really pleased with how I was able to modernize Florio's dictionary and the general genericness of the parser. I didn't have to special case a lot of the Italian words. So from this, I feel like it will be a good template to apply to other historical language dictionaries as well. For example, Randall Cochrane compiled his Dictionary of the French and English Tongues to provide French to English translations, and was actually published the same year as Florio's second Italian English dictionary. So I'd love to expand the site to cover many more languages. By the way, if you happen to know of any similar dictionaries, especially Spanish or German to English, do please let me know. That's all from me, folks. I hope you found this useful or at least interesting. I have a QR code here that will take you to the GitHub repo that's shown at the bottom. This will contain links to everything I've discussed here, as well as where you can find me on GitHub and Mastodon. Thanks very much for listening.